Starting in 3. Greetings and welcome. Here we are going over last night's homework. I think we're on page like 70. We're talking about solving systems. Last night we specifically were talking about solving by substitution. And some students were wondering about question 9 because question 9 is really ugly, right? Really bad looking. Specifically because we have coefficients in front of all of our variables that are not ones, right? Even if we had 1 to start with, that'd be nice. And probably even worse was this first equation that had all of these fractions. Now let me teach you a little trick. I call it fractionicide, in which you can actually kill all of the fractions in an equation rather quickly. Does anyone remember how to commit fractionicide? Kill all these fractions?
You just multiply by the reciprocal on the side?
No, not quite. Let's see, what's the LCD between 2, 3, and technically 1?
6.
6. So if I multiply everybody by 6, 6 divided by 3 is 2 times 1 is 2x. 6 divided by 2 is 3 times negative 3y would be negative 9y. And 6 times negative 4 is negative 24. So that'll at least kill the fractions for you. However, it's still, I think we're still going to end up with fractions in the end anyway, because between this equation and this one, I still have to pick one of my variables to solve for. I don't know, I might just pick this equation's x. I know it's going to create more fractions, but hey, let's see what happens. So that's what I'm going to do. I'm going to solve for that equation's x. So to do that, I'd want to move the y to the other side. So 9y, 2x equals 9y minus 24. And then to get x by itself, I could divide everybody by 2, like that. You could technically write this right-hand side as all over 2, but I usually find it better to just write it that way. So let's see, my revised equations will be x equals 9 halves y minus 12 is my revised equation. And the idea is that if this is truly equal to x, then that means it's equal to x all the time. So I'm going to plug this into the other equation for x. And sadly, 5 is not even, if only, alas. So let's see, we'll have 5 times parentheses 9 halves y minus 12 minus 4y equals 14, like so. And I'll want to use some distributing here, like that. So 5 times 9 is 45. 45 halves does not reduce y. Minus 5 times 12 is 60, if I'm not mistaken. Minus 4y equals 14. Woo. So let's see, I've got to combine some like terms here. I've got 45 halves y, which is what, like 22.5, and I've got negative 4y. So in order to combine those, I'm going to find a common denominator. So I'd have to multiply this one by 2 over 2, I believe, right? And I would get, what's that, minus 8 halves y that I could combine with the 45 halves y. Agreed? Disagree? Are we doing good stuff here? We cool? So let's see, 45 minus 8, what's that? 37 halves y. 37 is not only divisible by 2, I believe 37 is also prime at that. Yikes. Yikes. And then to get y by itself, we can move the 60. By the way, I would have been fine if you moved the 60 simultaneously up here. If you're a really talented algebraician, algebrite, if you're bright with algae, like some sort, whoa, what's that, bioluminescence? There we go. Then I don't mind if you do multiple moves at once, as long as you show your work like that. It's not bad. Man, bioluminescence, algebrite, I like it. 74 here. And I see some convenient numbers here. I don't know if you guys do. But to get y by itself, this is when I'd multiply both sides by the recip. And by the way, this is not the only way you could have done this problem last night using substitution even, right? Like, you could have ended up doing it a bunch of different ways. 74 divided by 37, I believe, is 2. And 2 times 2 is 4. And what do you know? Y equals 4. However, that is not our final solution. What should I do now? Yeah, we'll plug it into this little revised guy over here, since that's already solved for x. And x is the droid that I'm looking for. 4 divided by 2 is 2, times 9 is 18, minus 12, and I would get x equals 6. Like that. So, whew, problem took up a little bit of space, but yeah. So clearly, this is not a problem that substitution is excellent at. In fact, it's a little bit challenging. Today, we're going to learn some other techniques that might make this problem a little bit easier. But while you guys are still maybe adding some tweaks and corrections, is there another problem from the tarea that I could go over? Was that just the one beast problem that was tough, or? Okay, gladly. Let's see, would you say 21? Let's see. Wait. Let's see, let me see if I can up the exposure on that there. There we are. And paste. So here's problem 21. Now looking at this, immediately what I look at when I'm solving by substitution is a weak spot. I mean, in reality, okay, this perhaps is somewhat of a morbid analogy, but I play video games, so I'm thinking of it in that context. I think of substitution as being somewhat of the sniper rifle of the weapons you could use in solving one of these problems. And what you want to do with a sniper rifle in a video game is target the weak spot, so hopefully you can get like a single shot kill there. And so I see that this little y in the first equation is quite vulnerable to attack, right? So I'm going to target there. Whereas say like this last problem, man, like there was no weak spot. This guy was like wearing an overshield or something, and it was going to take more than one shot no matter what. So yeah, with substitution, you always want to target the weak spot. You wouldn't be wrong for doing one of the other ones. You're just making more work for yourself, right? So be aware of that. So let's see, 5x minus y equals 16. Solving for y, I would move, let's see, there's my cursor, minus 5x from both sides, like so. And I would have negative y equals negative 5x plus 16. And I'm fine if you just you could say you're dividing everybody by negative 1, multiplying everybody by negative 1, or you could just say I'm just changing the signs on both sides. I'm fine with that, and that would be a revised equation. And so therefore, if 5x minus 16 is truly equal to y, I should plug it into the other equation's y right there. And I would have 2x, what's that, plus 3 times 5x minus 16 equals 3. And I could do some distributing here, right? So 3 times 5x, 3 times 16, right? 2x plus 15x minus, what's that, 48, if I'm not mistaken. Combine some like terms, and tell you what, I'm going to do a double step here, specifically because I don't feel like switching yellow already. Add 48 to both sides and combine those like terms. Looks like we're going to have 17x on this side, and oh, is that an equal sign? That looks like a minus sign. How sad. Ugh. So 3 plus 48 is 51. And may be surprising, but I do believe 51 is divisible by 17. I'm guessing, yeah, 3 times. And that is only half of my answer. So now what I would do is plug it into the revised equation over here, and I would get y equals 5 times 3 minus 16, y equals 15 minus 16, y equals -1. And I'm fine with just having your answer that way, but like the kneecap question might sometimes want you to write it as an ordered pair. And that's what I want you to understand about these, is that we're solving a system of linear equations, technically. And so these are literally the intersections between 2 lines that we're talking about here. So you could think about it as an ordered pair, and it wouldn't be a bad idea. All right? So, thanks, Internet friends, for watching. Bye.